All right, guys, so this is section 3.7, and we are learning about angle side theorems. Okay, so we're going to be applying these to the measures of side lengths and angle measures of triangles. Theorem 20 states, if two sides of a triangle are congruent, then the angles opposite them are congruent. So this obviously has to do with isosceles triangles. You guys will see this a lot throughout your book, okay? And that just means if two sides of the triangle are congruent, then the angles opposite them are also congruent. So here's what I want to do is I want to make sure you guys understand what opposite means. So hypothetically, let's say they gave you that, angle A was congruent to angle B, and we have C over here. So this is an isosceles triangle. The base angles are angle A and angle B. Those are congruent to each other. The sides opposite them. So opposite A is the side that is not touching A. So here's my side. So opposite A would be BC, and opposite B is AC. So because those angles are congruent, so if these angles are congruent, then those sides opposite them would also have to be congruent. Oh, that was the next theorem. If those sides are congruent, switch this, and we'll use this example. If the sides are congruent, then the angles opposite them are also congruent. Oh my goodness, you guys, I'm a mess. Here we go. BC congruent to AC. If the sides are congruent, then the angles opposite them are congruent to each other. Now, same thing holds true. If the angles are congruent, then the sides opposite them are also congruent to each other. So again, let's do ABC. Only this time, let's say that angle B is congruent to angle C. Okay, so if angle B is congruent to angle C, then we know that the side opposite B, then we know that AC has to be congruent to AB. Okay, so if the angles are congruent, the sides opposite are congruent. If the sides are congruent, then the angles opposite are congruent to each other. That's theorem 20 and theorem 21. Also, here are the two ways that you're allowed to prove that triangles are isosceles. Prove that triangles are isosceles. So in proofs from now on, they're going to say like, prove triangle ABC is isosceles. If you can prove that two sides of the triangle are congruent, you know that it's isosceles. You're allowed to use that. If you know, and this comes from the definition, if you know that two angles are congruent, then you know that it is isosceles. So we'll be doing some examples of that, how to prove something is isosceles. But these are the theorems. So if you were writing a proof and you got this side equal to this side, you could then state, I know that this triangle is isosceles because if two sides of a triangle are congruent, then the triangle is isosceles. Okay? The next theorem. So if two sides of a triangle are not congruent. So let me draw this kind of obscure so you can see this. Okay, so if two sides of a triangle are not congruent, so I'm going to tell you that AB is not congruent to BC. Then the angles opposite them are not congruent. Okay, so opposite AB is the only letter that you don't see. So opposite AB is C. Angle C. Angle C is not congruent to opposite BC. We chose BC. Here we go. Opposite BC, which would be angle A. So these are not congruent to each other. And the larger angle is opposite the longer side. So hypothetically, if you knew that this was longer side, if there were numbers in here, let's say this is 10 and this is 5, I know that because BC is bigger than AB, because the blue side is bigger than the pink side, then the blue angle has to be larger than the pink angle. Okay, that's what this is saying. So if you have two sides of a triangle that are not equal, the angles are not equal. And the bigger angle is going to be across from the bigger side. Okay, the opposite is also true. If two angles of a triangle are not congruent, then the sides opposite them are not congruent, and the larger side is opposite the larger angle. So I want you guys to think about this. The larger the angle I create, so let's say this is an angle that I create right here. The side opposite, so if this is a 100-degree angle, the side opposite is going to be longer than if I had an 80-degree angle. Look at that side opposite. Look at the side opposite. The bigger the angle you make, the larger the side across from it is going to get. So that is the point of these. So you then know, you guys can kind of put this in order. So if I were to draw a triangle, again, kind of obscure, so A, B, and C, we'll do 5, 10, and 13. So here's my triangle, okay? So I know that the biggest side, I see the biggest side is AC, okay? Which means the biggest angle is opposite that, which is angle B. So AC is the largest, which means angle B is the largest. Okay, my next largest side is BC, and the angle that is creating BC is angle A. So because BC is in the middle, angle A has to be in the middle. Now, I don't know exactly how big it is, but I do know that it would be in the middle. And then if AB is the smallest, I know that the angle opposite AB, which is angle C, is also the smallest. So you can put them in order from largest to smallest based on the sides. You can also put them in largest to smallest based on the angles. Okay, that's what these theorems are talking about. And then we'll do some examples in class of this for the rest of this.